Okay. State and explain which point in the cycle the entropy of the gas is the largest. And there's 3 marks here. So it's like, and I feel like these marks are fairly arbitrary here. So let's think of 3 things we can say here. Okay. Well, let's think about this, right? From A to B, for cycle AB, heat flows in. Remember that the change in entropy is Q over T, right? Okay. Change in entropy is Q over T, right? So the change in entropy from A to B is positive. It increases, right? Because heat flows in, 416 joules of heat flow in, right? And then, of course, we could even calculate. It's one of the few processes where we could actually calculate the entropy, right? Because the temperature stays constant at 612 kelvins, right? But they're not asking us to calculate it, right? We just make an argument here. So from A to B, S increases, and that's because S is Q over T, and Q is positive, so therefore S is positive, okay? From B to C, okay, heat flows out, okay, so the entropy decreases. The entropy decreases from B to C, and the reason for this is that S is Q over T, and if you recall, Q is negative. So therefore S is negative, right? Okay, and then from C to A, the entropy is constant. And the reason for this is that S is Q over T and Q is 0. Right? Remember that Ca is adiabatic, right? Okay, so adiabatic compressions, adiabatic processes don't change the entropy. Okay? So therefore, if it increases from A to B, decreases from B to C, and C and A are at the same entropy, B must therefore, I believe, be the highest entropy. Yeah? In general, by the way, entropy just kind of increases this way, right? You have pressure and temperature and whatever, but, that helps. Does that help? That doesn't really help. Okay, good enough.